Kingston University and the RSC have lent us one of their infrared spectra. The infrared spectra works with something called an ATR, attenuated total reflection cell, which is a large diamond that the infrared light is able to reflect internally along, so that when you place a sample here on top of the diamond, then the infrared light reflects off it maybe 1,000 times, each time absorbing slightly into the sample. So if I show you how to set it up, first thing we're going to do is clean it with some methanol. We're going to wipe off the excess methanol and leave it a short time to evaporate. We'll then close this lever to force an anvil onto the diamond. We move over to the software and I'm going to start a new sample. So I click on Next Sample and I want to measure a background. Click. The background then scans through a spectrum in the infrared region 16 times. The reason we do this is because we want to make sure that we account for any water vapour or carbon dioxide that might be in the air that could interfere with our spectrum. Once we've completed the background, we can then move on to measure the sample. So we move back to the infrared, open the anvil, and then we take our sample. So the first sample I'm going to play with is some benzoic acid, which is a standard material that may be one of the drugs that has been found in the crime scene. So we add a very small amount of the sample onto the ATR. The diamond is right in the middle of the ATR, so we cover the diamond, push the anvil down, and now what we're doing is we're pressing crystals of the benzoic acid really firmly onto the ATR crystal so that the infrared light reflects off the surface of the benzoic acid crystal. We move back to our computer and we're going to try and measure sample. Now before I do that, I just want to show you this box, and this is showing us the parameters that we're measuring. Okay, and I especially want you to look at these squares here. Okay, resolution shows you how finely the infrared is adjusting the wavelength. So in this case, we're going to scan over roughly 4,000 centimeters. Okay, and we're going to scan every 4 per centimeter, which means that it's going to take 1,000 data points. This box here represents how many times it will scan. So the infrared will scan 1,000 times, or 1,000 data points, and it will scan it 16 times to make sure that our spectrum is as accurate as possible. We can increase this, but this would obviously increase the time it takes for the infrared to run, or we could decrease it, but then the spectrum would be less accurate. So, cancel this. So I'm now going to press Measure Sample, and I'm going to write in what my sample is. So we've got benzoic acid standard. Okay. Start our background measurement. Okay, and what I need to do, at the moment it's sitting there, it's doing a scan every now and then, which we can see if we press this. Okay, so that's given us an idea of what the scan will look like if we did one scan. So we then press Start Measurement in the bottom left, and it will then scan it for 16 goes. So we wait, and we see in this green line that it's telling us how many scans it's doing. You can see that it scans quite rapidly, which, considering that it's doing 1,000 data points, is quite fast. When it reaches 16, we shall see the spectrum come up. 16, okay. I press this button to make sure the spectrum fits on the screen. But we then have our sample. This area here is the fingerprint region. So called because it's so complex that you can't tell individual structures, but a computer can do a comparison. This feature here is a peak at roughly 1700, which relates to a carbonyl, a carbon double bond oxygen. This broad feature here represents an OH linked to an acid, so this is a carboxylic acid, and this tiny little peak here represents CH, showing that it's an organic molecule. Because we're computerized, the machine is able to do a matching search to a library of several 100,000 chemicals, which we press here to make sure we've selected it. So we select the spectrum, press this button to do a library search, and what the machine does is it compares our spectrum in red to all other spectrums that it knows about, and it comes up with a number here, okay, out of 1,000. The nearer to 1,000 this is, the more certain it is about that particular chemical. Now, the computer has not identified benzoic acid. In this case, it's identified something called phthalic acid, okay? But phthalic acid is essentially benzoic acid with a second acid group, so it's very similar. But because these two groups are the same, infrared cannot tell them apart. So it's telling us that we've got an aromatic acid, which is what benzoic acid is. Okay. Following having done the analysis, and when it's saved, all we simply have to do is clean again. So we wipe off our sample, put a bit of methanol on to make sure that we have cleaned all of the sample. And that has completed our analysis.